The chi-square test basically used to find out the difference when we have the two categorical data from the same sample population, or we can say the same population. So I have mentioned some images. So now the first thing, population. Of the same data set. So suddenly I took the example like female and male. So like, is there a relationship between gender and the highest level of education? So let's see, import numpy SNP and import pandas as PD, import scipy as stats, import chi-square 2 basically. It is the function of this one. So I want to check out there is any relationship between the higher education or not. So that is the question. So okay, so firstly I want to create the data. So the matrix, you know very well. Okay, so the data basically I want to. So firstly I want to create the dictionary, the data, female, like 6 comma 13 comma 16 comma 8 comma, that's enough. Similar I want to use 7 colon 16 common 15 common 11. You can see the data is there, but now the data is not into the proper tabular format similar to this one. So not a problem. So I want to print this data first. Now we have the data frame function in the panda. So like the data, like the note the data, like gender data, pd dot data frame and data. So gender data. You can see now the data is successfully show into this manner. Now one more thing I want to add. So now I want to pass the index number like without graduation. So not a problem. So I want to create the data like the education. So whenever we apply to perform this one, so the previous topic, it will automatically include it. So the first thing is without graduation. It is the first. Second, college. Then third, bachelor's degree. You can say the bachelor degree only. And the master degree. So now I want to pass the index. Very nice. So now class, you can see I have successfully create this data into this tabular format. Like if I'm talking about, so there is no necessary of this.
Sachin,
Yeah.
I am.
So now only I have used the data frame also. So there is now no need for the numpy. So it depend on you. You can remove it, but still they are necessary. Now second thing, it depend on you. You can show the data frame. So the print I want to use for these clarifications. So if you want to use, so you can see the data look like this man. So do not use this one.
You can write education level. Is it fine instead
Yeah,
of only education level of education or
I have
something?
provided this education to here into the index number. So it is just the index number. So now the question is that it demand basically data, not this one, data into. So the first data and the second data, data 2, data 2. So that is the clarification. I have supplied this one. Now still I want to supply the data. So dict is integer. Now I want to supply this data. Very nice. So now there is no need to do this. I have successfully, because when we are applying this contingency, so you can see it will not revert the single value. It will revert the so many value. So that is the problem unpacking. So unpacking means you can check from there, like chi contingency. So in the previous, I have used so many value, like the 4 value. So firstly, I want to check out why I have used so many value. So I want to check like there is any correlation. So you can see the correlation concept is also there. Mm, like correlation. So it depend on us, like if I want to supply the correlation true. Now I want to check the male and the female data sets are dependent or the independent. So the basically the categorized variables are same, dependent or not. So if the p value like we accept the null hypothesis, So there is the dependency of the data is not. So how we can say the data is dependent or not? Like if we want to check the data relationship with the help of chi-square, so we can also use from and scipy dot stats and import chi square, and chi square we can pass the similar gender data. Now you can see the p-value. Now similar, I want to print the p-value. Not the p-value, only p-val. So it will, the differentiation different. So it will work look like this 20 and this one, and it will look like this. So now I want to check. So I want to write the one more definition for the chi-square, like where we can use the chi-square contingency and the chi-square. So you can use chi-square when you don't know the underlying distribution and you want to test more than and two or more group have the same distribution and the distribution are same. But when distribution in my mind, but I'm not aware, I'm not sure, so we can use this chi-square. So that is the thing, like if I want to pass this value as a false, so this is not a, like it is optional, you can pass true and you can pass the false. So I hope I want to recall all this. Firstly, I have loaded, not the loaded, I have only clarified the data like the male and the female, like if there is any relation between the gender and the higher educations. So like when we are just increasing the higher education, so like the college 13, bachelor 13, little more master degrees also increase after the graduation, and it still it is also like increasing. When this increase, this also increase, it will increase after 13, 16 it will also like little bit not increase but still little bit compared to equal when it will be loud. So there is little bit difference. So now I have ready this data and provided this gender data to contingency and want to test when we accept the null hypothesis. We again I'm just inserting one more definition for more clarification. So now if p-value is greater than our specified alpha, that is 0.5%, so the threshold value, so we accept the null hypothesis, concluding there is no statistical significant difference between two. So both groups are same. If you want to calculate the mean, so the mean basically I think near about the same. How? Again the process, like how you can check out the mean. So sir, again we need the numpy. Import numpy as np, and you can also check out the mean with the help of panda and np dot mean, and again I have to supply the data female. Similar, I want to calculate the mean of male. So 11, and there is little bit difference. So you can see, so 91% accuracy. So we can say that the null hypothesis accepted. So there is no statistical difference between two group of the data. And we can say that the same distribution. So I hope today class I have discussed so many things this topic.